Time at rest, exploring the past, slowly. 1.85 million years ago, in the Caucasus region of what is now the Republic of Georgia, a small band of early humans gathers atop a hill overlooking an ancient lakeshore. They scan their surroundings for hunting opportunities and spot a small flock of deer grazing in a nearby meadow, a prime target. Having left the familiar savannas of Africa, this group recently entered a world no hominid has ever known. They move cautiously in this strange land, senses alert to every sound and shadow. The air is cool and humid, scented with damp earth, fresh leaves, and distant smoke. They are Homo Erectus. Long misunderstood as a mere evolutionary link to Homo sapiens, Homo erectus is in fact the most successful human species in history, enduring for over 1.5 million years, more than 10 times longer than our own species. They survived climate swings, ice ages, ecosystem collapses, and continental migrations without modern technology or agriculture. They did not come here to conquer. They came to endure. Following water and migrating game, they learn the rhythms of lands and climates, both beautiful and merciless. Forests edge open meadows and sunlight glimmers across the lake. Saber-toothed cats, giant cheetahs, and hyenas prowl the shadows. Every rustle, every distant call signals life, threat, or opportunity. Their bonds are their strength, silent coordination, careful teaching, and care for the weak or injured. Their arrival here is not marked by triumph, but by adaptability and perseverance. It is the first proven step of a multi-continental human species, taking tentative actions that will echo across millennia. Let us walk alongside these pioneering evolutionary cousins as we step together into the unknown. The story of Homo erectus begins not in the landscapes they once roamed, but in the minds and hands of the scientists who first uncovered their remains. Across Africa and Eurasia, scattered fragments of bones and stone tools hinted at a human-like presence. A species that had walked, hunted, and survived long before Homo sapiens even existed. The first of these discoveries that captured global attention occurred in 1891 on the island of Java in Indonesia. Eugène Dubois, a Dutch anatomist and explorer, unearthed a fossilized skull cap and a femur along the Solo River. He named his discovery Pithecanthropus erectus, the upright ape man, believing he had found the missing link between apes and humans. At the time, the idea of a long-lived, widespread hominin species challenged conventional thinking. Scientists argued over classification. Was it a modern human? A Neanderthal? Something entirely new? For decades, the Java fossils were an enigma, discussed, debated, and sometimes dismissed. The challenge of understanding Homo erectus continued with each new discovery. In the early 20th century, China became a crucial chapter in the story. Zhoukoudian, near Beijing, yielded a series of skulls, teeth, and tools that confirmed the population of ancient humans thriving hundreds of thousands of years ago. Yet even here, the evidence sparked uncertainty. Some researchers questioned whether the fossils represented one species or multiple forms. Regional variation, once thought to complicate classification, would later prove essential in understanding the adaptability of Homo erectus. Meanwhile, Africa remained the cradle of hominin evolution. Fossils from the Middle Awash and Ethiopia revealed transitional forms that connected Homo habilis, the handyman, to the more advanced Homo erectus. These discoveries emphasized continuity, demonstrating that evolution was not a series of abrupt leaps, but a slow, patient process. Alongside skeletal remains, archaeological evidence provided glimpses of behavior. Stone tools, simple yet effective, appeared across continents, sometimes alongside bones of large game animals. Hints of hearths and burned deposits suggested that Homo erectus may have mastered fire, at least to some extent. Sites like Wonderwork Cave in South Africa, dating to nearly 1 million years ago, preserve traces of in-cave fire, including charred plant material. Far to the north, in Israel's Gesher Benot Yaakov, repeated hearths reveal that Homo erectus may have maintained fires over generations, cooking seeds and perhaps even warming themselves during cold seasons. Yet such evidence remains sparse and debated. The scientific record is incomplete, filled with gaps that can only hint at the richness of life during the early Pleistocene. The early Pleistocene, the era in which Homo erectus first emerged, stretches from approximately 2.58 to 0.78 million years ago. It was a time of fluctuating climates, repeated glacial and interglacial cycles, and landscapes in constant transformation. Savannas expanded and contracted, forests retreated and returned, and rivers carved new paths through continents. Megafauna, from giant antelopes to prehistoric elephants, roamed these landscapes, offering sustenance to any hominin capable of endurance hunting or opportunistic scavenging. Survival required not just strength, but acute awareness of seasonal shifts, migration patterns of prey, and the availability of water. In such a dynamic world, small anatomical advantages, long legs for efficient walking, energy-efficient thermoregulation, robust teeth and jaws for diverse diets, could mean the difference between persistence and extinction. Scientific understanding of Homo erectus has been a story of gradual revelation. As more fossils surfaced, patterns began to emerge. Skeletal evidence showed a species with long legs, narrow hips, and a body plan remarkably suited to endurance. The discovery of Turkana Boy in Kenya, dated to roughly 1.6 million years ago, provided the most complete skeleton of Homo erectus known to date. This individual revealed not only a near-modern body plan, but also adaptations for heat management and long-distance mobility. Alongside Turkana Boy, the Ileret and Kobe Fora footprints, dating to approximately 1.53 million years ago, displayed a fully modern stride, a clear arch in the foot, and toe-off mechanics identical to Homo sapiens today. These traces, etched in ancient mud and now preserved in stone, confirmed what bones alone could not. Homo erectus moved through the landscape with efficiency and purpose, tracking resources and prey across vast distances. Yet the road to understanding this species has never been straightforward. Misclassifications, regional debates, and incomplete evidence have repeatedly challenged researchers. Java Man, Joe Kudian, and African fossils each sparked arguments about identity, intelligence, and behavior. Homo erectus was not merely an early human ancestor, but a species that endured, adapted, and thrived across a broad spectrum of environments for more than 1.5 million years. In comparison, Homo sapiens has existed for a fraction of that time. This longevity, more than brain size or technology, defines their success. Evidence of behavior, though fragmentary, underscores the resilience of Homo erectus. Stone tools, often hand axes of the Acheulean tradition, reveal both practicality and stability, remaining effective across hundreds of thousands of years with minimal modification. Burned areas, charred bones, and traces of controlled fire, as at Wonderwork Cave and Gesher Benot Yaakov, suggest that fire was gradually adopted and routinely used, shaping diet, safety, and social life. Fossil sites, such as Dmanisi in Georgia, dated to around 1.85 million years ago, provide even more intimate glimpses. A nearly toothless elder survived for years, cared for by the group, indicating social cooperation that extended beyond mere hunting or food sharing. Through all of these discoveries, the early Pleistocene context emerges as essential. Climatic swings, from ice ages to warmer intervals, forced hominins to be mobile and observant. Landscapes shifted slowly but relentlessly, shaping patterns of migration, hunting, and resource acquisition. Unlike later humans, Homo erectus did not rely on rapid technological innovation. Instead, endurance, flexibility, and cooperation ensured their survival. The species adapted to environmental pressures rather than reshaping them, following animals, water, and seasonal rhythms across continents. Ultimately, the scientific journey mirrors the life of Homo erectus itself, slow, incremental, and marked by resilience. Each fossil and footprint contributes a piece to the mosaic of deep time, revealing a species both familiar and alien, human-like in movement and ingenuity, yet profoundly shaped by the rhythms of a harsh and changing world. The story of Homo erectus is not just a chapter in human evolution. It is a testament to persistence, adaptability, and the patient accumulation of knowledge. The road to understanding this species has been long, winding, and often uncertain, but with each discovery, the image of a truly global, enduring, and remarkable human ancestor comes more sharply into focus. Before we continue, consider supporting long-form historical documentaries like this one by subscribing, liking, and leaving a comment. Share where you're watching from and what time it is. These small gestures help keep these stories alive, allowing more care, depth, and time to go into future projects. Now, let us follow their footsteps through deep time, tracing the quiet, patient rhythm of endurance and resilience. The forces that shaped not just a species, but the very story of humanity itself. Homo erectus emerged during a time of profound environmental change. The early Pleistocene, spanning from roughly 2.58 to 0.78 million years ago, was defined by oscillating glacial and interglacial cycles. Fluctuating rainfall, expanding grasslands, and retreating forests. These shifting landscapes presented both challenges and opportunities. Food sources were unevenly distributed. Seasonal variability demanded flexibility, and survival required a body and mind capable of long-distance movement, endurance hunting, and adaptability to unfamiliar ecosystems. It was within this crucible that Homo erectus evolved, setting the stage for one of the most successful hominin species in Earth's history. The evolutionary roots of Homo erectus can be traced to earlier African hominins, particularly Homo habilis, the handyman, and possibly Homo ergaster. Fossils from the Middle Awash region of Ethiopia provide critical evidence of this transition. These remains, dating to approximately 2 million years ago, exhibit a mixture of features. A slightly larger brain than Homo habilis, more elongated limbs, and body proportions adapted for long-distance walking. These adaptations would later define Homo erectus as a species uniquely equipped for endurance and persistence across vast landscapes. The skeletal changes were subtle, yet profound. Longer legs improved walking efficiency, narrow hips supported endurance running, and robust teeth and jaws allowed a diverse, omnivorous diet. Naming and classifying this new species proved challenging. When Eugène Dubois discovered the Java skull and femur in 1891, he named it Pithecanthropus erectus, reflecting both its ape-like traits and upright posture. The find challenged the scientific world, where evolutionary theory was still contentious. For decades, the Java discoveries were controversial, partly because of the scarcity of comparative fossils, and partly because Europe and Africa had yet to yield equivalent evidence. Only over time, as additional fossils emerged from Africa, Asia, and Europe, did the picture become clearer. These were members of a single, highly adaptable species, capable of thriving in a wide range of environments. China played a pivotal role in solidifying recognition of Homo erectus. For much of the early and mid-20th century, many scientists did think that Homo erectus and even modern humans evolved in China. This idea was especially strong in China itself, and became known as the Out of Asia or Chinese origin hypothesis. In 1921 at Zhaokudian, near Beijing, researchers uncovered skulls, teeth, and fragments of limb bones that confirmed the existence of a population living hundreds of thousands of years ago. Zhaokudian also provided tantalizing hints of fire use, later confirmed in specific layers. The Chinese fossils highlighted the regional variation within Homo erectus, differences in skull shape, size, and robustness, but reinforced the broader continuity of the species. At the same time, African fossils, such as those from the Middle Awash and later the Turkana region of Kenya, revealed a long, heat-adapted body plan capable of sustained mobility and endurance. The most famous of these, Turkana boy, discovered in 1984, dating to around 1.6 million years ago, is the most complete Homo erectus skeleton ever found. Turkana boy's long legs, narrow hips, and fully modern limb proportions illustrate a species finely tuned for walking, running, and survival in the varied savannas and river valleys of early Pleistocene Africa. Physical traits were tightly linked to survival. With upright posture and an efficient gait, Homo erectus could move confidently across uneven terrain, from river valleys to open grasslands, and cover the long distances needed to track migratory prey and reach dispersed resources. Footprints attributed to this species show a modern-style foot with a well-developed arch and strong toe-off, indicating walking mechanics much like our own. These traces underscore that long-distance mobility, rather than brute strength or rapid technological change, was a cornerstone of the species' resilience. Dietary flexibility was equally important. Homo erectus was omnivorous, capable of exploiting meat from hunted or scavenged animals, as well as a variety of plants. Teeth and wear patterns indicate adaptation to diverse food sources, while isotopic analysis supports a mixed diet that could shift with seasonal availability. Large herbivores roamed the savannas, and forests offered fruits, tubers, and nuts. This dietary flexibility, combined with endurance mobility, allowed Homo erectus to persist through dramatic climate fluctuations and environmental changes. The early Pleistocene context adds further significance. Glacial cycles drove shifts in habitat, forcing populations to adapt to changing water availability, vegetation patterns, and animal distributions. In open savannas, endurance hunting was feasible. In wooded valleys or floodplains, gathering supplemented diet and allowed survival during lean periods. These pressures shaped not only physical traits, but also social systems and behavioral strategies. Endurance and cooperation became more important than individual intelligence or innovation. The ability to observe, communicate, and navigate the landscape over long distances was critical to persistence. Recognition of Homo erectus as a single adaptable species required careful study over decades. Misclassifications were common. Today, consensus holds that Homo erectus represents a widely distributed, highly adaptable species that occupied diverse environments across Africa, Asia, and even parts of Europe. The species' success lies not in rapid innovation, but in stability, practical skill, and resilience. Archaeological evidence also provides glimpses into behavior and social life. Fossil sites, including Dmanisi, Georgia, reveal early Homo erectus individuals who survived injuries or dental loss, indicating care within groups. These early humans were pioneers in a literal sense, leaving Africa for new continents, gradually exploring Eurasia across generations. Environmental pressures, rather than cultural sophistication, shaped migration, hunting strategies, and resource use. Seasonal variability, availability of water, and animal movements dictated routes and patterns of settlement. Homo erectus' origins thus tell a story of patient adaptation. Evolution unfolded slowly, over hundreds of thousands of years, producing a species that could endure environmental upheaval without dramatic innovation. Brain size increased modestly, anatomy refined for endurance, and behavior optimized for cooperation and survival. Fossil discoveries, footprints, and stone tools form a mosaic of evidence, revealing not just a creature of deep time, but a species whose traits and strategies laid the foundation for later humans. In the early Pleistocene, Homo erectus did not conquer the environment through force or ingenuity alone. Instead, they endured. Their anatomy, their habits, their movements, all were finely attuned to the rhythms of a changing planet. From the shifting savannas of East Africa to the river valleys of Asia, they walked, hunted, gathered, and survived. Each fossil, each brookfoot, each hand axe recovered over the past century illuminates this slow, resilient story. The origins of Homo erectus are not just a tale of bones and tools. They are a testament to a species whose long journey across continents, climates, and millennia would shape the very foundation of humanity. Homo erectus was shaped as much by its environment as by evolution. The early Pleistocene landscapes of Africa, Asia, and Europe presented challenges that demanded endurance, flexibility, and resilience. Open savannas, river valleys, and woodland mosaics required a species capable of traversing long distances to track water, animals, and seasonal food sources. In response, Homo erectus evolved a body and mind finely tuned for persistence across space and time. A combination of anatomical efficiency, cognitive skill, and behavioral adaptability that set them apart from all other hominins. The first impression is striking. Homo erectus walked with a modern gait. Fossil evidence, combined with preserved footprints, confirms a body designed for long-distance travel rather than brute strength. The Alerit and Kubifora footprints in Kenya, dating to approximately 1.53 million years ago, provide a remarkable glimpse into locomotion. These prints reveal a fully developed arch, aligned toes, and toe-off mechanics nearly identical to those of modern humans. Each step recorded in ancient mud echoes across time, demonstrating that Homo erectus could move efficiently across diverse terrains, from grasslands to riverbanks. Foot structure alone allowed endurance walking and even persistence hunting, a strategy of tracking prey over hours or days until exhaustion forced it to yield. The skeletal record reinforces these observations. The discovery of Turkana in Kenya, around 1.6 million years old, offers the most complete insight into Homo erectus' body plan. Standing remarkably tall for an 11-year-old, at about 5 feet 3 inches, with long legs, narrow hips, and a lean muscular frame, Turkana illustrates adaptations to heat and distance. Long limbs improved walking and running efficiency, while thermoregulatory adaptations allowed survival in open, sun-drenched landscapes. The skeleton shows a species built for movement, not sudden bursts of strength, but sustained activity, endurance, and the ability to explore vast areas in search of food and water. Robust shoulders, hands capable of precise gripping, and a spine structured for upright posture all contributed to the remarkable efficiency of Homo erectus's movement. Cranial anatomy further illuminates the balance between intelligence and practicality. Homo erectus had a brain size ranging from approximately 600 to 1,100 cubic centimeters. Smaller than the modern human average, but sufficient for planning, coordination, and problem-solving. Skull features include prominent brow ridges, a long, low brain case, and a somewhat projecting face, suggesting a brain optimized for functional practical tasks rather than abstract thought. These cognitive abilities likely supported cooperative hunting, tour-making, and knowledge transmission, even without complex symbolic language or artistic expression. The brain, paired with a body built for endurance, created a synergy that allowed Homo erectus to thrive in unpredictable environments. Dietary flexibility was equally central to survival. Dental wear patterns and isotopic analyses reveal an omnivorous diet, including both hunted meat and gathered plant resources. Early Pleistocene ecosystems provided varied food opportunities. Megafauna roamed open grasslands. River valleys offered fish and tubers, and forest patches supplied fruits and nuts. Teeth adapted to this diet show wear consistent with hard, fibrous plant material, as well as processed meat. The ability to exploit multiple food sources, combined with endurance locomotion, allowed Homo erectus to persist through fluctuating climates, dry seasons, and unpredictable resources. Behavioral evidence complements anatomical adaptation. Tool use demonstrates both cognitive planning and functional precision. These tools, sometimes symmetrical, sometimes rough, were versatile and long-lasting. The durability of these tools speaks to the efficiency and sufficiency of Homo erectus's problem-solving abilities. Fire, though adopted gradually, became a central feature of life. Evidence from Wonderwork Cave in South Africa, dating to approximately 1 million years ago, provides the earliest secure in-cave fire use. Farther north, at Gesher Benot Yaakov in Israel, hearths preserved charred seeds, wood, and burned flint, demonstrating repeated, controlled fire use around 780,000 years ago. Fire transformed the daily life of Homo erectus. It allowed safer cooking of meat and plants, warmth in cooler climates, and a central gathering point for social interaction. Yet fire was not sudden innovation. It was incremental, habitual, and practical. Integrated gradually into routines that had already proven successful over hundreds of thousands of years. Anatomy and behavior combined in ways that emphasized endurance over raw strength or innovation. Long-distance travel mattered more than rapid sprinting or hunting individual prey. Social cooperation amplified survival. Fossil evidence shows individuals surviving dental loss or injury, likely cared for by group members. Similarly, Turkana boy indicates prolonged growth periods and social support structures within groups. These behaviors suggest that Homo erectus relied on group networks for knowledge transmission, resource sharing, and collective protection. Endurance and cooperation were as essential as the ability to walk or run. Ecological context shaped both anatomy and behavior. Early Pleistocene Africa and Eurasia were dynamic landscapes. Expanding savannas encouraged persistence hunting, while forests and river valleys offered diverse plant foods. Climate cycles forced Homo erectus to adapt to fluctuating rainfall, shifting vegetation, and changing availability of prey. Anatomical adaptations, long legs, efficient gait, heat regulation, enabled movement through these environments. Behavioral adaptations, tool-making, fire use, social cooperation, enabled survival through environmental unpredictability. Together, body and mind formed the blueprint of resilience, capable of sustaining a species for over 1.5 million years. Even the limitations of Homo erectus provide insight. Brain size, though smaller than modern humans, was sufficient for planning and coordination without necessitating symbolic culture. The species did not need rapid innovation to survive. Stability, endurance, and adaptability defined success, rather than technological sophistication alone. In essence, the anatomy of Homo erectus tells a story of endurance, adaptation, and survival. The early Pleistocene was a world of repeated glacial cycles, shifting rivers, and moving herds. In this world, Homo erectus thrived. They were neither the fastest nor the strongest hominin, but their combination of physical and cognitive traits, behavioral flexibility, and social cooperation created a species capable of remarkable endurance. Over 1.5 million years, their anatomy and behavior remained effective across continents, climates, and landscapes. Long before symbolic art or written language, Homo erectus mastered the essentials of survival, demonstrating that success in the deep past was measured not by rapid innovation, but by resilience, persistence, and the ability to endure. Homo erectus is traditionally credited as the first hominin to leave the cradle of humanity. Around 1.8 million years ago, populations began to move beyond Africa, exploring new lands across Eurasia. This migration was not sudden, nor marked by grand expeditions. It was a gradual, generational process, guided by the rhythms of the environment, the movement of animals, and the seasonal availability of water and food. Each step was measured and deliberate, a slow expansion across continents that would ultimately establish Homo erectus as the first truly global human species. The Dmanisi site in Georgia, dating between 1.85 and 1.7 million years ago, provides the earliest evidence of Homo erectus outside Africa. These fossils reveal a population already adapted to long-distance travel, capable of surviving in temperate environments far from the savannas of East Africa. Their presence in Dmanisi shows that Homo erectus was able to adjust to new climates, vegetation types, and prey species while maintaining the same successful body plan and survival strategies honed over hundreds of thousands of years. Migration was shaped by endurance rather than technological sophistication. Long legs, efficient gait, and thermoregulatory adaptations allowed Homo erectus to walk for hours, following animal herds, rivers, or seasonal water sources. Unlike later humans, who relied on complex transport or storage systems, Homo erectus depended on the capacity to move continuously, carrying knowledge, tools, and social connections with them across generations. The migration into Asia was gradual and repeated. Fossils from Java, such as Dubois' original 1891 discovery and later sites across Indonesia, illustrate that Homo erectus populations successfully occupied tropical forests, river valleys, and volcanic highlands. In northern latitudes, Zhoukoudian China provides evidence of populations adapting to colder climates, where fire may have become a regular feature of survival. In these varied environments, Homo erectus relied on behavioral flexibility rather than dramatic innovation. Stone tools, fire, and social cooperation provided a reliable framework for survival, while physical adaptations allowed movement across challenging landscapes. Environmental pressures dictated migration routes. Seasonal droughts, expanding grasslands, and fluctuating river systems channeled populations along predictable pathways. Rivers, lakes, and coastlines acted as guides, while the movements of prey herds provided both sustenance and direction. This careful following of ecological cues ensured that Homo erectus could colonize new territories without significant technological reliance. In contrast to Homo sapiens' later innovations, success for Homo erectus was measured in distance traveled, food acquired, and groups maintained over multiple generations. Fire played a supportive role in adaptation to the cooler climates of the north. In cooler regions, fire may have been essential for survival during glacial episodes, while in warmer climates, it allowed for more flexible foraging and the safe consumption of food. Yet, fire, like tools, was not revolutionary. It was practical, habitual, and consistently applied across generations. Migration also involved social strategies. Survival in unfamiliar environments required cooperation, sharing resources, transmitting knowledge of plants and animals, and protecting weaker group members. Knowledge of seasonal patterns, animal behavior, and safe routes would have been transmitted orally or through demonstration, a form of proto-communication that enabled long-term survival without formal language. Social learning ensured that knowledge accumulated slowly but reliably, allowing Homo erectus populations to persist as they moved across continents. The consequences of this migration were profound. Homo erectus became the first hominin to inhabit a truly global range, establishing populations in Africa, West and East Asia, and Southeast Asia. Each region presented unique challenges: dense forests, arid savannas, riverine wetlands. But the core strategy remained the same: endurance, cooperation, and practical use of simple, effective technology. Regional variation emerged, not as a failure of adaptation, but as evidence of flexibility within stability. African populations retained traits suited to heat and long-distance walking. Asian populations adapted to cooler climates and new resources. Yet all shared the signature Homo erectus anatomy and behavior. The early Pleistocene context magnifies the significance of this migration. Glacial cycles repeatedly reshaped landscapes, opening and closing corridors of movement. In periods of cooling, populations may have clustered near rivers and lakes, following prey herds and exploiting stable ecological niches. During warmer intervals, expansion across open savannas and forested valleys was possible. This slow, incremental dispersal contrasts sharply with later human migrations, which relied on innovation, symbolic knowledge, and cultural acceleration. For Homo erectus, endurance and adaptability were sufficient to conquer continents. Migration also solidified the species' role as a pioneer. The ability to establish populations in new habitats laid the foundation for all subsequent hominins. Neanderthals, Homo sapiens, and later populations inherited strategies first perfected by Homo erectus: long-distance travel, flexible diet, social cooperation, and incremental technological refinement. In this sense, the migration of Homo erectus was not simply a geographic expansion. It was the spread of a behavioral template that would resonate through human evolution for millions of years. Migration was not a gamble. It was a carefully honed practice, perfected over generations and guided by ecological awareness. Ultimately, the migration out of Africa reveals the essence of Homo erectus, a species defined not by fleeting innovation, but by endurance, adaptability, and resilience. Each fossil, footprint, and hearth tells a story of persistence across space and time. The species moved slowly, carefully, following water, prey, and seasonal cues. Their reach extended across continents, creating the first truly global human population. This expansion highlights the core lesson of Homo erectus: survival over deep time depends less on brilliance than on consistency. cooperation, and the capacity to endure. From the river valleys of East Africa to the forests of Java, the plains of Georgia, and the caves of China, Homo erectus left traces of their journey: bones, footprints, tools, and hearths. Each tells of a species intimately connected to its environment, moving patiently across landscapes shaped by climate, animals, and the rhythms of nature. The migration of Homo erectus is not just a story of movement, it is a story of survival, adaptation, and the enduring power of a species finely tuned to the challenges of the early Pleistocene. Homo erectus thrived not because they innovated constantly, but because they perfected survival. Their technologies were simple, stable, and remarkably effective, shaped by the demands of the early Pleistocene rather than by bursts of creativity or abstract experimentation. Over more than 1,000,000 years, they mastered fire, developed reliable tools, and relied on social learning to transmit knowledge across generations. These achievements were not sudden revolutions. They emerged slowly through observation, repetition, and careful adaptation to landscapes that shifted with climate, season, and time. In a world defined by uncertainty, Homo erectus built a culture grounded in sufficiency. Stone tools form the most visible trace of this technological tradition, not because they were the most important, but because they survived. Among them, the Acheulean hand axe stands as one of the longest-lasting technologies in human history. First appearing in Africa early in the species' existence, Acheulean tools spread across much of the Old World and remained in use for over 1,000,000 years, with remarkably little change. Their form, bifacially shaped, symmetrical, and carefully worked, was simple, versatile, and reliable. Hand axes could cut meat, process plants, scrape hides, dig for tubers, and break apart carcasses. They were not specialized instruments, but adaptable solutions, suited to many tasks and environments. Their persistence does not suggest stagnation, but confidence. These tools worked, and so they endured. The consistency of Acheulean technology across vast distances and deep time points to strong traditions of social learning. Tool-making was not an instinctive act, but a skill learned through observation and practice, passed from one generation to the next. Tools were likely shared within groups rather than owned individually, and knowledge of how to make and use them was embedded in daily life. Survival depended not on solitary invention, but on collective memory. What the archaeological record shows only in fragments is the role of perishable materials, especially wood. Stone tools dominate the evidence, not because Homo erectus relied solely on stone, but because stone survives while wood decays. It is highly likely that Homo erectus made extensive use of wooden tools, even though direct evidence is rare. The combination of stone technology, hunting behavior, and anatomy strongly suggests woodworking played an important role in daily life. Stone tools would have been well suited for shaping wooden shafts, removing bark, and hardening tips over fire. Among the most plausible, though not yet definitively proven, technologies are simple wooden thrusting spears. Later hominins are known to have used carefully shaped wooden spears, and there is little reason to believe Homo erectus lacked the ability to produce simpler versions. Wood may also have been used for digging sticks, carrying poles, simple shelters, and food processing implements. These tools would have expanded Homo erectus's technological world far beyond what stone alone reveals, leaving behind only indirect traces of their use. Fire was another technology that reshaped Homo erectus life, though not all at once. Evidence suggests that fire was gradually incorporated into daily routines, rather than adopted in a single moment of mastery. Once fire became habitual, its effects were profound. Cooking increased the digestibility of food and widened the range of edible plants and meats. Warmth allowed groups to occupy cooler regions and remain active during colder seasons. Light and smoke reduced the threat of predators, while hearths created predictable gathering places within camps. Fire altered daily rhythms, extending social life into the night and providing a stable center around which knowledge, food, and protection could be shared. These technologies functioned within a broader cultural system, shaped by cooperation and coordination. Homo erectus likely engaged in group hunting, particularly of large herbivores, using strategies that required shared planning and an understanding of animal behavior. Cooperative foraging supplemented hunting, with groups gathering plant foods according to seasonal availability. Such behaviors imply complex vocal communication, sufficient for coordination even without symbolic language or grammar. Cultural knowledge was not written or depicted, but embodied in repeated actions, gestures, and shared routines. Each generation learned not by innovation, but by participation. The environments of the early Pleistocene rewarded this stability. Repeated glacial cycles, shifting rainfall patterns, and changing ecosystems demanded solutions that worked across a range of conditions. Acheulean tools could be used in open savannas, river valleys, and forest margins. Fire provided warmth during cooler periods and protection in exposed landscapes. Wooden implements, though largely invisible to archaeology, likely filled countless everyday roles. Rather than specializing narrowly, Homo erectus relied on a flexible but conservative technological toolkit that could be carried across continents and adapted without reinvention. Regional differences reveal variation within this stable framework. Open landscapes favored endurance hunting and the processing of large animals. In parts of Asia, cooler climates and mixed forests increased the importance of fire and flexible foraging strategies. Despite these differences, the underlying behavioral template remained consistent. Homo erectus did not pursue symbolic expression or rapid technological change. Their success lay in persistence, cooperation, and a deep familiarity with the rhythms of the natural world. Over time, fire, tools, and shared knowledge strengthened social bonds. Hearths and shared meals became opportunities for teaching and reinforcement of group identity. Skills were passed from elders to juveniles, not through instruction alone, but through repeated observation and participation. Technology and culture were inseparable from social life, each reinforcing the other across generations. The technological story of Homo erectus reveals a fundamental truth. Innovation was not necessary for success. Acheulean tools, fire, woodworking, and social learning provided everything required to survive across continents and climates for more than 1 million years. Their culture was not defined by art or symbols, but by reliability and endurance. Each hand axe, hearth, and likely wooden implement reflects a species attuned to sufficiency rather than excess. Homo erectus's legacy is written not in monuments or imagery, but in deep time itself. From the river valleys of East Africa to the forests of Asia and the caves of the Levant, their technologies and behaviors sustained them longer than any other human species. In their quiet mastery of survival, Homo erectus left behind a blueprint of cooperation, resilience, and practical intelligence that still underlies the human story today. The success of Homo erectus rested not only on physical endurance or environmental tolerance, but on social coordination. In the unstable landscapes of the early Pleistocene, survival was rarely achieved alone. Food acquisition, movement across territories, and protection from predators required cooperation, shared knowledge, and mutual reliance. The fossil and archaeological records preserve only indirect traces of this social world, yet together, they suggest that Homo erectus lived within tightly knit groups whose internal coordination was as vital as any anatomical adaptation. Some of the strongest evidence for this social structure comes from individuals who survived despite serious physical limitations. At Dmanisi, remains include an elderly individual who had lost most of their teeth, yet lived for years afterward. In isolation, such an individual would have struggled to feed themselves. Their survival implies tolerance, provisioning, and a willingness to support non-productive members of the group. This kind of care suggests long-term bonds and a recognition that group survival outweighed short-term individual efficiency. Such behaviors reduce risk for all members, making dangerous activities, such as hunting large animals or long-distance movement, more viable. Social coordination was also essential for learning. Juveniles required prolonged care and instruction, and the knowledge necessary to survive was accumulated gradually through observation and participation. Young individuals learned where animals tended to gather, how landscapes changed seasonally, when to approach or avoid water sources, and how to behave during group pursuits. This learning was not symbolic or abstract. It was embodied and situational, reinforced by repetition and shared experience. Cultural continuity emerged not from rapid innovation, but from consistency, doing the same things, in the same ways, across generations. Hunting provides one of the clearest windows into Homo erectus social organization. With evidence increasingly suggests that hunting was cooperative, rather than solitary, involving multiple individuals coordinating their movements and actions. Small and medium-sized animals could be taken opportunistically, but even these encounters benefited from shared vigilance and rapid group response. Larger prey, including megafauna such as ancient elephants, horses, large bovids, and giant deer, would have required collective effort. Bringing down such animals demanded timing, patience, and an understanding of animal behavior that extended beyond any single individual's experience. Group coordination likely took advantage of landscape features. Water margins, lakeshores, marshy inlets, and narrow corridors naturally concentrate animals and limit escape routes. Multiple individuals could position themselves strategically, applying pressure from different angles and guiding prey toward predictable paths. Such coordination does not require complex language, but it does require shared expectations and practiced routines. Later archaeological sites, such as the Shonin horse assemblage, demonstrate how pre-modern humans used lakeside environments for collective hunting and mass processing. While these sites postdate Homo erectus, they offer a plausible behavioral analog for earlier coordination strategies rooted in similar ecologies. Communication during these activities was likely achieved through gesture, posture, vocal calls, and learned signals. The consistency seen across repeated occupations of favorable locations suggests that groups followed established patterns rather than improvising anew each time. This implies a form of shared planning embedded in routine. Knowledge of where to stand, when to advance, and when to retreat would have been learned socially, reinforced through success and failure alike. After a successful hunt, social coordination remained critical. Large carcasses could not be exploited effectively without multiple individuals working together and sharing the rewards. Cooperative access to food reduced competition within the group and reinforced social bonds. Such sharing also allowed groups to buffer against unpredictability. When one individual failed, others could compensate. This collective approach made risky strategies, such as pursuing large or dangerous prey, sustainable over the long term. Risk buffering extended beyond hunting. Injury was an unavoidable consequence of life among large animals and predators. Yet the archaeological record shows individuals who lived long after serious trauma. This suggests that groups tolerated temporary or permanent dependency, redistributing effort to ensure group continuity. In this way, social life functioned as a stabilizing force, absorbing shocks that would otherwise threaten survival. Regional variation likely shaped how these social systems expressed themselves. In open environments, groups may have spread out over wider areas, coordinating movements across animal pathways and regrouping at water sources. In forested or riverine settings, coordination may have emphasized repeated use of smaller, resource-rich zones. Despite these differences, the underlying pattern remained consistent. Cooperation, shared knowledge, and mutual reliance formed the backbone of daily life. For Homo erectus, social organization was not an abstract concept but a lived reality, enacted through movement, cooperation, and shared risk. Groups functioned as integrated units, capable of coordinating complex activities without formal language or symbolic systems. Through patience, repetition, and trust, they created a dependable social framework that allowed them to endure across vast distances and immense spans of time. Long before art, ritual, or written memory, the foundations of human society were already taking shape in coordinated footsteps, shared vigilance, and the quiet agreement to survive together. Homo erectus occupies a singular position in human evolution, not because of any one defining innovation, but because it established a durable pattern of survival that endured across deep time. For more than 1.5 million years, this species persisted through changing climates, shifting landscapes, and expanding ranges. In doing so, Homo erectus created the physical, behavioral, and social foundation from which all later humans would emerge. The evolutionary transitions that followed were not abrupt departures from this model. They were subtle adjustments laid onto an already successful framework. Later hominins inherited a body designed for movement and efficiency, a lifestyle organized around cooperation, and a way of engaging the world that favored persistence over excess. These traits proved resilient in the face of environmental instability, allowing populations to adapt without constant reinvention. One of the most important legacies of Homo erectus lies in how biological and behavioral changes became integrated rather than isolated. Brain expansion, for example, unfolded slowly and unevenly across regions, reflecting local conditions rather than a single evolutionary trajectory. Cognitive growth was sustained not by abstract intelligence alone, but by behaviors that made larger brains viable, predictable access to food, shared knowledge, and coordinated group activity. Intelligence in this context functioned as an extension of practical life, rather than a separate evolutionary goal. This balance between cognition and ecology set the stage for later developments. When subsequent species displayed larger brains or more complex social behaviors, they did so within a framework already stabilized by Homo erectus. The returns on increased mental capacity were supported by strategies that reduced daily uncertainty and spread risk across groups. In this way, the legacy of Homo erectus is not found in sudden leaps forward, but in the steady alignment of biology, behavior, and environment. Regional variation within Homo erectus populations further illustrates this pattern. Across Africa and Eurasia, groups adapted to local climates and landscapes, producing differences in body proportions, cranial shape, and behavior. Yet these variations remained connected by shared principles: endurance travel, cooperative living, and reliance on stable practices. Over time, these regional distinctions would deepen, giving rise to new hominin lineages. But the core template remained recognizable, demonstrating how flexibility could coexist with continuity. The transition from Homo erectus to later species was therefore not a replacement, but an inheritance. Neanderthals would refine cold climate adaptations. Homo sapiens would develop symbolic culture and accelerated innovation. Yet both did so while relying on strategies first stabilized by Homo erectus: collective provisioning, shared learning, and movement across large territories. The foundations of later human diversity were laid not by disruption, but by accumulation. Social organization stands out as perhaps the most enduring contribution of Homo erectus. Cooperation was not an abstract moral trait, but a practical solution to uncertainty. In this sense, social life itself functions as a form of adaptation. Longevity provides the clearest measure of this success. Few species in the human lineage matched the temporal span of Homo erectus. While other hominins appeared briefly in specialized niches, Homo erectus occupied a wide range of environments over immense stretches of time. This persistence was not driven by dramatic innovation or dominance over nature, but by the ability to remain viable as conditions changed. Stability, rather than spectacle, proved to be the most effective strategy. Even the fragmentary nature of the fossil and archaeological record reinforces this conclusion. Much of Homo erectus life remains invisible, voices unheard, shelters dissolved, daily routines unrecorded. Yet what endures? Footprints, hearth traces, and familiar tool forms speaks to repetition rather than novelty. These remnants reflect the species that relied on what worked, returned to known solutions, and passed them on reliably. Later humans would add art, ritual, language, and cities, but none of these developments would have been possible without the groundwork established earlier. The human story did not begin with symbolism or civilization, but with endurance and shared effort. The legacy of Homo erectus is therefore not one of disappearance, but of continuation. Every later human carries traces of this long success in body, behavior, and social structure. The paths we follow, the distances we traverse, and the ways we rely on one another echo choices first made by a species that learned how to last. Through patience, cooperation, and resilience, Homo erectus carried humanity into the wider world and left a foundation strong enough to support everything that came after.